10.1, simplifying radical expressions. So a square root is a radical. Let's, before we get into the more rule-based stuff, let's ask ourselves a couple questions. If I were to write square root of 36 like you see it here, will that end up being the same as the square root of 4 times 9? And the reason I chose those numbers is 4 times 9 is 36. They're not random. And I've also written it this way, where I've broken apart the square root of 4 here and the square root of 9 here with a times symbol in between. But notice that I'm not saying anything involving addition. All of this is back-to-back multiplication. There's no parentheses or anything going on, so keep an eye out for that. So starting off on the left side, we know what the square root of 36 is because that's just 6. On the right side, the square root of 4 is 2. The square root of 9 is 3. And if I multiplied 2 times 3, I would get 6. Now, of course, one example isn't enough to really prove something, but I do like to test things out to see if it seems realistic to me. And I guess looking at it this way, if it's under the radical, I could recombine 4 and 9 to make 36, and that's definitely true. So it seems to me that I kind of believe that you could break apart through multiplication in their products whatever you'd have under a radical to end up getting true statements. I think that's totally okay in these types of problems. And now that we look at it with real numbers, I could say, well, the square root of 4 times 9 will be equal to the square root of 4 times the square root of 9. So what it's saying is that two numbers under a radical multiplied can be broken apart into their separate parts. Now notice that I saved the words in the description of what this is last. For any numbers a and b, where both a and b are greater than 0, and the reason for that is that it really avoids messing with negative numbers, the square root of the product, so here's the square root of the product of AB, is equal to the product of each one broken apart. I think that's pretty clear as we look at it, and I do definitely feel that the symbols make the most sense. And so since the word product means multiplication, we're talking about the product property of square roots. This right here is going to be basically a resource and your go-to if you need it. But if I square 1, I get 1, 2, I get 4, 3, I get 9. And the reason I'm constructing this is that whenever you're dealing with square roots, you want to be able to take the square root of something to get whole numbers to be able to simplify these radicals. Now, if you had something like the square root of 5, you'd be a little bit stuck because that would fall between perfect squares. So you'd have to get a decimal there. I'll go ahead and complete this, and you can do it on your own too. Of course, the table stops at 12 squared because that's where most people kind of cut off what they know. You can memorize 13, 14, and 15, but it's going to be less common than these main 12 and really the first 10 or so. Pause that, get caught up if you need to. Now, simplifying square roots. Here I have the square root of 90, and the way I like to do these when I simplify them is that I'm going to write the square root of 90 on the left, and I'm going to write equals. Now I have to figure out, what can I turn this into? Well, I could turn 90 into 9 times 10, and I think that's going to be totally perfect. But really, the best way to do these is to always look for the largest possible perfect square. So I really wouldn't even consider 100 because that's bigger than 90. 81 doesn't make sense. Really, as you go on, none of these fit nicely into 90. 25 doesn't go into 90. 16 doesn't. So the largest perfect square that will fit in to 90 is going to just be 9. Now for this one, you might never even bother thinking that. I could write this radical out as 9 times 10 if I like the way it looked there. But if I really make it look like the property we just learned, we can break 90 into 9 on the left and 10 on the right. and then 9 will turn into 3 because I'm taking the square root of it. And then I think about, well, what can fit into 10? Well, 10 has 2 times 5, but neither of those give me perfect squares. And then other than that, it's just 10 and 1, and that doesn't take me any further. So I could write this as 3 times the square root of 10, but whenever we see things back to back, we know that I can just write 3 square root of 10. And here's what I'd like you to do for this problem. I'm going to be clicking away, and what you're going to hear on my keyboard is me actually typing in the square root of 90. And the reason I'm having you do that is because you're going to look at your calculator and see that the square root of 90 as a decimal is about 9.5. But then I also want you to take 3 times the square root of 10 and type that in as well. And once I type that in, I see that that is also about 9.5. And I'm really using my calculator as a tool on these because radicals are a little bit confusing for people, and that calculator can really help you experiment, because if you test something out and you see that you get the same exact results as the beginning problem, then you can probably safely say that your test worked out just fine. Now, you don't have to really do these horizontally to this direction if you don't want, so you could just work below, but I do kind of like the way I organize these. So here's the square root of 27, and again, I'm thinking about my buddy 9. But if I did use the resource, 25 isn't going to work. 16 is not going to fit into 27, but 9 absolutely will. So here I got this broken into 3 and 9. Maybe I do a quick little sanity check to make sure I got 3 times 9 is 27 and I'm good. Well, I can't do anything with the square root of 3, but I do know that the square root of 9, which I'll trace in blue, can turn into 3, and then I'll just rewrite the square root of 3. And the reason I color-coded that is so that you could see how I shuffled it, because what you're going to end up having a lot of overlap in is, you got a 3 here, which is not the same as this 3. So make sure that you're able to track this work. Pause this, give that a quick check, and use that in your calculator and make sure it's okay, and then move on. Here I got square root of 150. Okay, now we have larger numbers here. Might be nice to use a resource. I'm probably thinking about the numbers 10 and 15, though. Well, none of these would make any sense. 49, well, that's close to 50 times 3 is 150, but that's short. Well, maybe 36 works out, so maybe I pull my calculator out and I do the opposite of the multiplication, which is division, and I divide those two numbers. And we'll say, well, 150 divided by 36 is a decimal, so that's a dead end. So I move on. 150 divided by 25. Oh, let's check this out. And I get, let's see, 2, 4, 6, 8. I misspoke there. I just get 6. Whoops, and that's a terrible 6. And hey, I think that's going to end up being the right choice. So let's go with 150 being the same as the square root of 25 times the square root of 6. Now notice that like this time, I actually do have my perfect square on the left. You could do some planning ahead, but I think that these are kind of complicated enough to where you don't want to be thinking all over the map. So I got 5 square root of 6, type that into your calculator, make sure that that is true. Now just to prove a little bit of a point, I'm going to have 150 down here, and I'm going to write that as square root of 10 times the square root of 15. Well, I could think of square root of 10 as 2 and 5. Square root of 15 is square root of 3 and square root of 5. And these two guys would multiply out to get rid of each other. And the 2 and the 3 could get reconstructed on the inside to become 5 square root of 6. Now, I did that quickly because that's not really what you're learning right now, but I'm showing you that there are other ways to go about these. But notice that that was probably more complicated than trying to find this perfect square of 25 on this page. So yeah, there's a lot of different ways you can go about these. This is multiplying square roots. And sometimes the nicest way to go about these is to always try and simplify first. By the way, let me say something about simplifying. I didn't do an excellent job of explaining this. You know that these are simplified when you can't pull out any more perfect squares. So I said that kind of with 10 being 2 and 5. Well, only 1 and 3 go into 3. And then even though 6 is a composite number, and it's non-prime, it can only turn into 2 times 3, and neither of those are perfect squares. So a lot of your training is going to make you want to simplify this further. So there's going to be times where these problems are finished, and you probably won't even believe that you're done, but you are. So that's a good reason to check the back of the book and make Wolfram Alpha a resource for this, where you can just type simplify in. All right, so multiply square roots. In the last ones we just simplified it, but here we have things that we can combine or whatever. So if I have 3 times 15, then the square root of 3 times the square root of 15 will end up being the same as the square root of their products on the inside. So I'll just write 45 on the inside. And then here on the right side, I'm trying to think of numbers that go in that are perfect squares. And whenever I see 45, I'm definitely thinking of 9 times 5. So it's like we did multiply to put them back together, but we are headed towards simplifying in the end. So that might seem a little strange, but the instructions are always to simplify. And the square root of 9 is 3, and the square root of 5 only has products of 1 and 5, so you're stuck there. And that is a finished answer. Now the square root of 5 and the square root of 10 become the square root of 5. I forgot, honestly, what I was saying because somebody came into the room. I think I was just rewriting the problem. Square root of 5 times the square root of 10 is going to end up being recombined on the inside. And like I said earlier, there's no plus signs. There's nothing like, variables and stuff going on the inside here and under radicals. So this is only multiplication happening. And if you have a good understanding of that, that's awesome. I can put those together and make it square root of 50. And although I'm thinking of 10 times 5, that's what we just had. And we couldn't simplify either of those at the start. Square root of 50. Let's see. 25. And it's kind of strange sometimes to grab such large numbers. Times 2 gives me 50. And the square root of 25 is 5. And square root of 2 is stuck being itself. Now, if you ever see a problem like this, square root of 9 times square root of 2, don't turn that into 18 again. The work's already done for you. So just remember, look for those easy guys. Don't become such a robot as you do these, that you do it the same way over and over and over. Square root of 6 times square root of 8, rewrite it. Now notice that I'm keeping these pretty neat, but my times symbol is almost under that radical, so I use my eraser to go back. Radicals need to cut off at the correct spot. The square root of 2 plus x is not the same as the square root of 2 plus x, like where it's all in parentheses. So if you cut the radical short or let it go too far, minor mistakes can be made. It looks like I'm running out of room, but I think that'll be fine. So I'm going to turn this into the square root of 48. And then 48, maybe you jump back to your little chart, and you're like, well, I'm not going to try 49 because that's bigger. 36 is ridiculous. 25, well, does 16 times some number give me 48? Well, 16 times 3 does, and so you're going to be good there. So I'm going to rewrite this as 16 and 3, and square root of 16 becomes 4, and the square root of 3 gets written right there. And like before, type these into the calculator, give them a quick little check. And just to plant the seed, these all can be rewritten different ways. Like this far left one, there's my square root of 3. There's 15 becoming 5 times 3. And then these guys become 3 square root of 5. That'll be a little bit more clear with more practice in later chapters and sections. So we've multiplied square roots in these last types of problems, simplified square roots in these types of problems, But it's all about multiplication, and even though you probably have all this memorized, I hope that using it as a resource and working your way backwards can help you kind of be more efficient at these problems. And even though you really have it locked in, I think this is a good exercise. It's helped me do these over time too. This is the first of a few videos for this section.